I think let's get started to keep on the schedule. Welcome to the second session of the Choosing the Right Inspire Download service. In this second session until 12:30, we have a nice set of presentations from covering the web coverage service group, which is one of the new extensions to the download service specifications or the technical guidance. This is presented by Jari Reini. Then we have a couple of use cases. One is for the meteorological data that's from the Finnish Meteorological Institute about their SmartMet server implementation, which implements both web feature service and web coverage service, and uses that for meteorological data provision. Then we have another case study from BRGM, which involves both web feature service and sensor observation service. And then we have a nice 20 minutes time for discussion, and I would like to ask you already to think about what you want to what questions you have in mind for that discussion session. So I have just a few here to start with. So how to match the different data sets into the different download service technologies, for example. So if you have cases where your organization has been providing or is thinking of providing Inspire data sets, how to match each of the themes and each of the data specification data models into some of these technologies presented here and the previous session. So Atom, web feature service, web coverage service, and sensor observation service. And the other question could be about the, for example, the themes and the data models. Do you think that the current data models in the data specifications are imposing some difficulties when you're using certain technologies, for example? So is it easy to map certain data models into SOS or web feature service or web coverage service? Or do you need actually a combination of all of these or some of these? So just to get started, I would like to welcome Jari Reini to talk about the web coverage service group. You need to swap.
Yeah, it doesn't respond at all.
Oh. We have the presentation here.
But it's slightly different. Okay. Welcome back to the wonderful world of three-letter abbreviations. Now we are talking about WCS, web coverage service, and how to extend the Inspire guidelines for using WCS. My name is Jari Reini. I'm a head of department for SDI services at the National Land Survey of Finland, and I'm also a representative in ISO TC211 and OGC for technical stuff from National Land Survey. I will start with a few words about what is coverage, and then going through some examples, and then the kind of a key point, how to map implementing rules to technical guidelines, and some of the roadmap. The technical guidelines is not yet finished, so I will talk a few words about that. First of all, how many of you are aware of coverages and WCS? Are you familiar with that? I know Peter is absolutely, but what about you else, Mikko, some others? So coverage is quite a clever thing, that it's kind of a raster format with the source code inside it. So you may have more information, like not from WMS you just get an image, but from WCS you also get more information, the source of the geospatial image, like elevation or temperature. I have in next slides a few examples. So it can be used for complex modeling and analysis, so to be used in a clever way, and of course clients can extract just what they need. We are in this particular case, when we are talking about coverages, we are talking about quite big data. So some of the clients are maybe not capable of taking all the huge data as one file, but with web coverage service you can extract just what you need. Some of the formats, JPEG 2000, GeoTIFF, ASCII, GRID, NetCDF, etc., for different use cases, different formats. You will get these slides from the Inspire website later on, so here are links to some examples from British Geological Survey, and also a screenshot from a subset by area, just an image there to be shown. And I took one example of time-space slicing. It's actually an image by Peter Baumann, where you have different information in different layers, in this case about temperature in 2012 and different days. So these are kind of use cases. You can extract more information, not just an image, but actual attribute information with different channels and subsets. And also a more multi-dimensional example here. There's a live demo in British Geological Survey website as well. You can walk through if interested in. Okay, why the Inspire WCS profile is considered to be quite important. One of the main reasons, some of the Inspire teams are obviously coverages like orthophotos, digital elevation model, or meteorological data. I think we will have a nice presentation from Mikko from Finnish Meteorological Institute, how to expose meteorological information using their SmartMet server shortly. If you don't have WCS, then it's atom feed, and you just get huge files, and those are maybe not that usable in many use cases. And of course, some teams can be modeled using WFS. So the current technical guidelines for download services includes WFS. We had presentations about SOS as well, and WCS will be there as well in the future. Some of the advantages, direct access to subsets of big data, some processing, new projection, format conversions, to get content in different resolutions, etc. And you just take what you need. You may have different use cases, and you take the content what you really need. So that's the reasoning behind using WCS in download services. Some of the possible themes, not all the themes, but starting from elevation, going through to energy resources. So especially from Annex 2 and 3, the content or themes are to be used in exposing WCS. Then we are going into the implementing rules. Most of you have seen this picture as well. So on the top we have legally binding information, so implementing rules. And in technical guidelines we are showing how member states might implement it. So it's not legally binding, but it's for your information how you can actually put your content and services available. So we have ongoing work for WCS, and now I'm going through a little bit of mapping how implementing rules can be mapped to technical guidelines. Ilkka had some information about mapping in his introduction presentation, and I pretty much have same kind of information here. So in terms of download services, network services regulation describes 4 mandatory download operations, namely get download service metadata, get spatial dataset, describe spatial dataset, and link download service. So we are first going through these 4 mandatory, and then we have this nice where applicable thing. So it's not voidable, but it's where applicable operations. But let's start with these 4 operations. First, to have get download service metadata. So revealing information about the service, about datasets and the service capabilities. And as you may be aware of, all OGC standards, get capabilities is the key operation for this particular interest. Furthermore, additional metadata can be get using WCS describe coverage operation to get information about coverage itself. This is pretty straightforward and is mapped quite well to implementing rules. Then we have a get spatial dataset, so to get actual content, and it's get coverage request, what can be used for this purpose, and you can get information in different coordinate systems, language, etc. So different parameters as well. Describe spatial dataset. Describe coverage is the one to be used in this case, and also quite easy to map and use. 4th operation, link download service, is about publishing metadata to inspire compliant discovery service, so to get metadata information from discovery like CSW. If we are going to these conditional, where applicable operations, those shall be implemented and are get spatial object, as well as describe spatial object type. Get spatial object gives you different abilities to search content using unique identifiers, some attributes, different temporal dimensions, like in date of update, B-box, bounding box, so the corners of the content, by data team, and of course as a combination from all above. Then we have faced some challenges in describe spatial object type, and really a question, can WCS describe coverage satisfy all the requirements for a described spatial object type operation? And our recommendation in technical guidelines is that WCS download service should have only one representation of a spatial object type per service. So these are the 4+2 different operations which are described more in details in the technical guidelines document. And then we have these other requirements included in all download services, to have language information, to have quality of service information, in this case get coverage to have 40-70 kilobytes, more than 5 seconds to respond, and language parameters, language equals to English, Finnish, Spanish, etc. So these are same for all download services. Where are we right now? We sent the document some time ago out for comments. We got I don't remember how many comments, but 42 pages, and if having 5 comments per page, maybe 200. I really counted all of them. Some of them were editorial, some of them pretty generic ones, and some more technical. But all of them have now processed by the group, and now we are working on release candidate 2 and send the document for MIC-P review and possible endorsement. We also have put some sample coverage data sets available to different sites. Here are links, and you can use those later on. And also we will continue work on thematic clusters page, inspire thematic clusters, to continue the discussion and have a dialogue between the group and all the data providers and end users. So if you are not aware of these Inspire thematic clusters, this is the page, how it, the starting point. So teams.jrc.ec.europe.eu, quite many words, but you can find it by having Google and Inspire thematic clusters. So this is the place where we have a continuing discussion about the work. This was briefly what I had in my presentation. I have the document, I have all the implementing rules, but I don't want to kill you here, so you can look at those later on. So all the requirements and recommendations are included in the document. Go ahead, it most likely will be the final one, so you can start to implement, to extend your current WCS capabilities using the document. If there are some minor changes, those are really minor ones, so all the big things are already there. And the document is available at Inspire MIC-T website. Maybe I should put a link to this presentation where you can look at the document yourself. So that was all from my side. Any questions, comments, etc.?
Yes, please. So any questions about this presentation or the mapping of the web coverage service into the Inspire download service requirements in general? Please, welcome. There are no stupid questions, so I'm sure that there will be 10 more people who will thinking about the same thing that you are thinking, so please come forward. Yes.
If I understood it,
A bit closer to...
if I understood it correctly, you wrote the specifications. Do you have already the technical implementation also tested against it? Can you maybe elaborate on that one as well?
Sorry, I didn't hear.
Did you implement it also technically? So do you have a reference implementation of what you have now specified?
There are implementations available, for instance, from Peter Baumann, Rasterman, and there are some implementations also in GeoServer as an open source version. So technical implementation has been done during the project as well. Would you like to comment something from your side? So Peter Baumann is also a member of this group working on.
Okay. Thanks, Jari. Peter Baumann speaking. I'm editor of the WCS specification in OGC, and there we actually do have a conformance test suite that is established and that is available via OGC. And there are many implementations, both in open source world and proprietary. You find an increasing number of implementations, which gives a nice platform and actually vendor independence if you use WCS.
Any other questions, comments, while I'm doing this technical work at the same time?
I would like to ask some kind of clarification question. Was there a question? Okay, please.
Hi. We haven't started to implement the service yet. And if we would like start, want to use open source software, is that GeoServer is a good place to start?
At least GeoServer is one point for there, but there are other solutions as well, a map server as well, and I'm pretty sure that Peter can help you as well for the implementation work, so these are the starting points.
Thank you.
Maybe it's worth emphasizing that you're not left alone there. So there is support and there is contact points so that technical questions can be answered easily. And what I would like to add as a PS to my previous remark, actually these conformance tests allow to test down to the level of pixels. So we do not just test metadata or so, but also the values of pixels of an implementation. So if it gets that brand, that it's OGC conformant and I guess in future Inspire conformant, then this will mean that these servers all deliver the same information, exactly the same information, and that means you can use them interchangeably. So that gives degrees of freedom.
And just to add that this guideline is using WCS 2.0 version, not 1.0 or 1.1. So we are starting with version 2.
Sorry, there's one.
Hello, I have no technical question, but only I want to know, will you provide these services for free or will for payment?
Do you mean by having the final service how to expose? It can be free or it can be charged. So it's like in any other download services. But it must be provided to commission freely. But for the end users, it's up to you. As coming from Finland, I support heavily open data and services.
Thanks. are there plans to upgrade the guidelines for VCS 2.1 in the future?
At least it hasn't popped up in my mind, but do you have any knowledge about that? I think Peter, as an editor for the stuff, can have.
I'm sorry, I keep you running. So, first of all, about the versioning. So WCS 1.0 and 2.0, they differ in the major version number, and according to OGC rules and regulations, that means incompatible changes. So they 1.0 and 2.0 are not compatible. There was a big learning curve, which has resulted in 2.0 to do things better today. Now, what is 2.1? There is just a minor version change, and that means backwards compatibility. Actually, 2.1 is pretty much the same as 2.0 for just one thing. It allows more coverages. What does that mean? The coverage implementation schema in OGC is progressing currently from 1.0 to 1.1. We have added further grid types and a few other things I can report on if it's of interest. And 2.1 simply says, okay, a WCS should allow the old coverages plus possibly the new ones. So it's just extending, but it's backwards compatible. So for now, it's not a big difference whether you use 2.0 or 2.1, it will be compatible, so you can upgrade anytime in the future.
Thanks. Now it's clear.
Okay, unless there are very quick questions, we can return to the questions after the two presentations. So one is, let's have a presentation from the Finnish Meteorological Institute by Mikko Visa, and it's about SmartMet-based service for meteorological data using web feature service and web coverage service.
Thank you, Jari. My name is Mikko Visa. I'm with the Finnish Meteorological Institute, and I'm going to talk about two of our implementations. That's web feature service and web coverage service. Just a little background. We opened our data in 2013. That meant basically everything that we have IPR for property rights, and the basic idea was, of course, to open it in a freely and in a machine-readable format. So this presentation is going to be about two implementations. We have had web feature service and VCS-like implementation for some time now, and we are currently implementing web coverage service. So that's work in progress, and I'm going to show what we have up until now and what's the future roadmap for that one. But first about the web feature service. It's based on 2.0 and a simple profile, which does mean that the predefined datasets that we heard about before. In practice, it's stored queries with the possibility for additional parameters. So you can specify time, area, and what parameters, I mean, for example, meteorological parameters you can put in the URL. And this is in-house production. It's based on our data server, SmartMet server. That's a big software suite that most of our production is based on. If you are interested, you can hear a presentation about SmartMet server on, I think it was on Thursday, by Roope Tervo. It's currently being open sourced, So basically the web feature service and the web coverage service that we are implementing will be open sourced by the end of this year. We have had it in production since 2013, so about 3.5 years now. And what you can get is observations and point forecasts in GML format in 3 different flavors. That's the grid series, observation, and point time series, and then there's the simpler feature. Other names for the first 2 ones are that's multi-point coverage and time series. Could be more familiar for someone. Then we have the gridded data. That's of course in appropriate format, depending a bit on the data. Currently you can ask the web feature service that what's available, and it gives you the metadata or a link to the actual data, which is then RIB 102 for weather models and mostly NetCDF then for the sea models, and GeoTIFF for radar images. And the production of point forecast is basically we have the forecast model data on the file system, and our server reads it into memory, holds everything in memory. It's a memory map technology. And then we have our web feature service plugin, which is the interface to the data, and it gives the formatted INSPIRE compliant XML, GML response back to the user. Grid forecasts, a bit like the point forecasts. We have the model data file system, and then the server reads it, and you have the web feature service plugin that gives the response, but now in addition there's a link to the actual binary data. And the actual binary data currently is provided by a so-called download plugin. This is a web coverage service like download service, but it's not standard. But basically it does most of the things that the web coverage service also specifies. That's in the next slide. So this is what's currently in production. So it provides grid data as binary. Output formats are GribNet, CDF, and the last one is an internal format of ours. Supports projections, and then you can select slices by area, bounding box, or elevations, up or depth in sea models, and of course time. And then you also can define the grid resolution if you want it in something else than the original one. Yeah, so this is basically a lot like web coverage service, but without the standard interface. Web feature service basics. So first of all, of course, you start with get capabilities, like in many services. I'm first going to show how it works in observations and point forecasts. There's an example URL. So first you query the get capabilities, and then there's the describe stored queries operation, which lists and describes all available stored queries. That's the predefined data sets that we have specified. There's something like 40 of them or something like this, and you can find them all on our web page. But the stored queries also take additional parameters. For example, time, area, and so on. Then there's get feature, which is the actual data query. So the only mandatory parameter is the stored query ID. And other parameters depend on what stored query you are using. And what you can give to it is described in the describe stored queries request. Basically, often you have to specify some kind of locational. That could be a bounding box. It could be an ID for the observation station. For example, WMO ID. Or then it could be just a geo ID. We use geonames.org for the locations. And then you can also specify just a human readable name, for example, Barcelona. And that can be used several times in one query, so you can get many places in one response. Or then you could just use Platlon coordinates. So, what if you only want to get just some specific bit of the response? Well, then you can use get property value, so that you can only get some part of the get feature response. And here you can use XPath to define the actual path in the XML to what you want to get. There's an example down there. Still, you can use some additional parameters, even if you use get property value. So, for example, you can specify the place also here. So this is how it works currently for observations and point forecasts. Binary data is basically the same response as in observations and point forecasts. But then the result contains the domain set defines the grid, and range set contains the data, but that's now an external link to the binary content. So, for example, you can see in the URL, you can see the download question mark, and after that it goes to another service than the web feature service. So, file reference, well, it points to the other service, but that other service can also be used directly. So our so-called download plugin can be queried directly, but we recommend that it's good practice to consult web feature service so you can get the available times and parameters and what's available just at that moment. So the basic idea is to first ask web feature service what is available. And this is mostly about SmartMat server, but we also use GeoServer, the web map side of it, for radar images. So, for example, if you want radar images as geotiffs, those are served from GeoServer currently. So, area time and parameters which mean the actual data parameters, for example, temperature and so on. Those can be defined in the requests. For weather models, an intersection of the requested area and available data area is returned. But then for radar images, all images which intersect requested spatial and temporal space are returned here. Radar images, the reference points to an original grayscale geotiff image, but they can also download as color images. So for example, you can download as a PNG file or something like this. Then of course you lose information. If you want to use the SLDs that we use, we have put them up on GitHub. Then also for those knowing a bit more about radar measurements, you can get just some parameter elements. For example, scanning angle, bin count, and bin length. That's radar images. Then numerical models. The reference links often points to a subset in the model output. So as I said, GRIB for weather models usually, and NetCDF for marine models. But of course, in these cases, the output can be quite large, up to 17 gigabytes currently. So it's usually recommended that you just specify the area parameters and time range of interest. And this is, of course, the idea and case also in a web coverage service.
You have 5 minutes.
5 minutes, yeah. Okay, then just quickly about the web coverage service implementation, which is in progress now. So we are basing this on the same server that we host the web feature service on, the SmartNet server. The biggest motivation to use the same is that it's really easy to integrate into our production system. So we can basically just build a web coverage service interface, and we have all the data available already. And we can easily just put it up, basically. Current support is 2.0.x. We have get capabilities with Inspire metadata. We have describe coverage, where you can find the valid time, area levels. Then we have get coverage, so that you can get the whole data in the native format zeros. You can slice or trim with the X, Y, Z, and time dimensions with key value pair or XML posts. The time can be given here in more user-friendly ISO format, or then you can use Unix time. Format NetCDF is partially implemented currently, and GRIB 1 or 2 is coming later. And then I have a whole set of examples here of what you can do with it. I'm not going to go into every example, but these are here for reference if somebody just looks at the presentation later on, so it's nice to have some examples. But let's skip these and go to what's not implemented and what's challenges, which might be more interesting. There's no support for the MetaOcean web coverage service profile yet. That's to be done. Web coverage service 2.1 was discussed here a bit. GRIB output, yes, that's coming. Well, we intend, of course, to put it as our open data Inspire interface, just to replace the non-standard one. Challenges. Okay, we have many weather models are usually when being rotated lateral or some exotic formats. And for example, many times the order of latlon, or is it lon lat, that depends on the CRS. So you never get it right on the first time usually. Time intervals, do you have a start time :end time, or do you have start time / end time, or so on? How to define a data set. In Inspire, it's sometimes just a new version of it, but when the data is upgraded like every 1 minute, 5 minutes, so a lot of versions then. Well, reproject on, I think, not so much in web coverage service, but there's often a need for this at least in the MetaOcean domain. What's been challenging also is the lack of clients so far. It's quite hard to test. For example, if you had some easy QGIS or something like this. So far, we're playing around with the web browser. Then the dimension, okay, we have now X, Y, Z, T, which you can do slicing and trimming. But then there's the question of parameters, for example, meteorological parameters, temperature, and so on. Currently, I think the schema doesn't allow to put those as a dimension, so you couldn't slice and trim. So now, if I go back to one example, so we have, for example, coverage ID is HBM salinity. So in the coverage name we have the meteorological or marine parameter. But I don't know if this could be a dimension at some point, maybe. And then, of course, in meteorology, there's an ensemble prediction system that has many models in one, how to manage those and probability forecasts and so on. Yeah, I still have a lot of experiences, but I can skip those already if time is short. So.
Very good, very good. So, any quick questions to Mikko about their kind of? I think this is pretty much groundbreaking work actually in the field of meteorological data and open data. So I think this is very interesting.
Unless somebody else has questions,
Sorry, just make fun.
Thank you. So, especially for a challenges slide, I would like to respond. But we could do it offline, but maybe it's good also for the audience to see this kind of interaction.
Yep.
So, from bottom to top, dimensions. So, you mentioned one option that you could have a different dimension, an extra dimension that does it. But also you can have composite cell values. So like with hyperspectral images, where you have lots of pixel colors in your cell, the same thing you could do here. So you could have velocity in XY, salinity, or whatever in one cell. And then you have the range subsetting extension, which allows you to extract from that.
Okay.
And then your users can obtain whatever they want. They don't need to have the full payload of, say, 50 variables or so.
Yeah.
So that is an option. About the reprojection, no, first, clients. We are working with many clients like Leaflet, NASA Whirlwind, QGIS, and we do that on WCS2. So I don't know whether the code supporting WCS2 is in the official repositories. If you need access, then please contact us.
Yeah.
We can give you pointers or the code. And we also have an own client, which is browser-based, but you don't need to type the full URLs yourself. That might be helpful.
Yeah.
So there are options.
Okay.
Reprojections.
Good to hear.
Sorry, I'm jumping ahead quickly. What's the issue, actually? There is a CRS extension which allows to formulate reprojection. Where do you see the issue?
Okay, I didn't know about that extension actually. I would have to ask about this one because I'm not so familiar with projections.
Okay. And then maybe we can proceed on this offline.
Yeah, I think so.
Could you please go back then to the previous slide? So CRS challenges, okay, this is something we just addressed.
Yeah.
And the rest is also something maybe more complicated to discuss in offline. So thank you, that was my way of responding immediately.
Yeah, thank you.
Other questions to Mikko? Or about how they actually implemented the Inspire web feature service and are on their way of doing that for web coverage service? If no questions, thank you, Mikko. It's a very nice presentation. And the next one is the Michael and Francois from BRGM.
No, would be mine. I prefer, do you have VGA or should we be HDMI?
So we try with
So the title of the presentation is Implementing Inspire Web Feature Service and
no problem.
Sensor Observation Service for geoscience data. The technological cocktail to quench the user's thirst for data.
Okay, so my name is Michael Bofis, and I will talk about what we've done in BRGM, which is a French geological survey, about implementing Inspire WFS and source for geoscience data. And for this presentation, we call it the technological cocktail to quench the user's thirst for data. So as you can figure, this will talk about cocktail. So you can see what we call the BRGM the work cocktail. And well, we will deal with all of these components. So as you can see, this is an Inspire compliant cocktail. You can see there is a pineapple size on it, on top of it. And it's composed of WFS app schema, also a sensor observation service, and we also have identifier and resolver. This is a very important point. That's what the user will see when they will look at the cocktail, and we also have to deal with user interface that we are using, what we are developing in the BRGM. So we will start with WFS app schema. So basically, that's our image representation of what we are looking at when we are trying to implement WFS app schema. Well, you have first the administrator side that, well, the user side don't see the same image as an iceberg. So you have database modeling, which is an important side. After that, developers have to look at the tool installation. We have to choose the tool before. Tool configuration that we enable, well, as a test to get some basic usage. After that, some advanced usage. So basically by using filtering. And if we want to get something sustainable, well, we have to look at also about update and maintainability and performance and scalability. This is the only way that the services can be used in a production mode. So basically, in BRGM, we are using three tools to provide WFS app schema. We have Constellation, GeoServer, and Degree. As you can see, all are Java-based. And on the other slide, you will see that well, the different use cases we have and the implementation. So we have geological units, faults and boreholes, that are used for the EPOS and EGGI projects that are implemented by GeoServer. We also have some water level piezometers that are provided by GeoServer 2. We have other kind of use case by shorelines, aquifer units, mineral resources, and the last two are provided, one by Constellation and the other one by Degree. You can see that well, we also have a proof of concept of using GeoServer for aquifer units and mineral resources. First thing you have to know that, well, it depends. It's for us, it's some kind of fashion. We are, well, as for now, GeoServer is it's very used. We also have some use case with Degree Constellation where it's so here is of subjective feedback when we try to implement the data with those tools. Well, at the moment, we find that we are not totally satisfied by any of those implementation. With Constellation, we have some difficulty to configure and to update our services. With Degree, we also have some constraints, such as a database with its structure to be very close to the diffusion schema. We also have some filtering issues that have been emphasized in 2015. And well, for GeoServer, we have also some bugs. One of them is with Earth Resource ML, we have data duplication, which is a bug of this tool. We have found that configuration of app schema is also, well, it's also very tricky, and we also have some performance issues on the complex features. So, but this is not a totally wrong feedback, because we have also positive aspects, because, well, for basic usage, all our get feature by ID works, and the idea we have is, should we define store queries or forbid other filter combination to have some advanced usage that can work and that can actually work, but without breaking down the server. So that's what we are looking for at the moment. So here is a representation of what is actually done. As I said, for the moment, tool configuration for app schema, this step is a bit too high, and this make our structure becoming very wobbly, and performance scalability and update compatibility have to be increased if we really want to get an advanced usage that is actually not really realized by our implementation, even if basic usage is okay. So as you can see, at the moment, our cocktail is quite threatened, and the idea, especially for this presentation, is can we team up to finance necessary evolution? Can we team up to make a good WFS app schema tool work and to save our cocktail? So that's the main question, the main proposition. For the sensor observation service, well, we have basically the main discussion. We have to find which solution to deploy, or to map to pre-existing and non-observation measurement compliant databases. We ask ourselves how to design the raw observation database, and how can we link the features observation. So we choose to use the 50-degree north solution. At the moment, we have a raw observation schema database, which is very close to OM schema, which is actually a constraint. We use materialized views to bridge to our raw database. And actually, we also have one web app which is set up by use case. So as we are dealing with the use case at the moment, we have some, well, groundwater lovers raw observations that are provided with the point time series observation. We have also validated data, which is a work in progress, and we are working on the groundwater quality, borehole logs also. We almost specified how we can do the mapping between the concept to the databases. And we also have other work in progress with geothermal properties and coastline erosion in other projects. So here you can see a presentation of what is done for groundwater raw data levels. We have some GPRS piezometers that push the data hourly, and those data are stored in a FTP as files, and then we have a process that enters the data in the observation source raw databases with OM schema-like, and these are provided by the 52 node solutions. So you have an idea of two kind of get observation. One is to get water ML2 format data, and the other one to get JSON format here. So the main thing we can say about our work on the source, it's really worth the effort, because we got a lot of reuse. We have some websites. We also develop a QGIS client plugin. Well, I will deal with you. Just after that, you can see here we got a website for geothermal, so they can look at the temperature of the devices they have. We have, thanks to 52 node solution, we have a map of our sensors. We have also some representation of the observations. We are actually working on using some models to get some predictive data and to complete the observation. So this is very a good point for us. And also, last but not the least, our domain colleagues are very happy about this. And this is very important because for them, well, Inspire is much more about metadata, and now they can have a test of Inspire and see that this is very important to get the data, interval data, and well, as it's enabled to get more projects and have a good team for breaking up the interoperability. So it's a very good point for us. The third point is about identifiers and resolvers. As we have spoke about, we have been able to provide data services, and well, we have not to forget for the people that will use the data. And for them, this is very important to have something which is readable. So the idea of using URIs to linking data is to provide stable and resolvable links to resources. We also want to allow reference and data citation and to be independent from underlying technologies used to provide data. So I will show you an example. So here you can see we have an aquifer with a piezometer. You can see we have some information. We know that this aquifer has a name, an identifier. We also can see that this piezometer also have an identifier, and the idea is to be able to link data. It's to link the piezometer to the aquifer, and also to his data observation. So you can see some information that this aquifer is monitored by this piezometer, and this piezometer has also a lot of observation concerning this aquifer, and you have a link from the piezometer to the actual observation. So this is the idea of the URIs, and that's you can see how we do this. So you will see the aquifer units. We also have environmental monitoring facility. We also have some environmental monitoring network, and you have the possibility with a source and, for example, to get the link and the WFS2 to get the link between those different elements. So, for example, you can have this environmental monitoring facility as observation, and you have links to those observations, and well, you get all the tools that are needed to link all the data you have. And the idea of using identifier is, well, you can use some URI to link the data. And this is especially very important because, as you can, we don't have the same tools that are used to provide the data, and so they won't be based on the same database. And this is very important to have some independent links. So when we worked on implementing those identifier and resolvers, we have discussion about identifier nomenclature. Should we name this HTTP resource .brgm or resource with one S in English or two S like in French? Use pluralism, resources or resource separators. We also have to define specific identifier. For example, if we have some data which are basically based on the same concept but based on different formats, should we have one identifier per format, or can we use the same identifier and specify a format after that? We also had discussion about data version, also data granularity. Finally, we made some choices. So here is a link to our actual data, which is HTTP resource in French, .brgm.rec because it's still in validation phase, .fr, .france. And we also have, after that, we have data, observation, vocabs for controlled vocabularies, also services that we are using. And at the moment, we have a proof of concept Apache routing rules that enable to link the data. So I will show you an example. Here is a kind of identifier we have. So this is identifier, and if you enter this on your computer, then it will create, with the rewrite in proxy mode, it will create this request, and this is something that the Constellation WFS schema tool will understand and provide the data after this. So you get also other examples of this concept. We also have information about one piezometer, so this is basically the same as for the aquifer. And we also use the same concept for getting some observation. And if we want to specify which kind of format we want to get, we can express this at the end of the URI. And so the conclusion of this thing is, well, identifier and resolver, as far as it's just a Curacao in our cocktail, this is what gives the color, and this is of the cocktail, and this is the thing that the user will see, in fact. Last point is about user interfaces. Well, the idea is
you have 5 minutes, Cecil. 5 minutes.
Okay. Is that we want to enhance Inspire services readability, emphasize data connectivity, and also break the no client, no data loop. This is what we have with our domain colleagues, because they say, well, we will provide our data with Inspire, but we don't have any tool to get it and to use it. So we wanted to break this loop, and we provided a tool. This tool has been funded by BRGM and developed by the French company Auslandia. And this tool is actually a QGIS plugin, which is available for download. You can have it for now. And it has been developed for QGIS version 2.14 and the next one. So this QGIS plugin will be presented on Wednesday in the Inspire conference, but I will give you an overview of it. We have 2 modes. Basically, we have here an XML mode. In fact, we can load the data, and if we click on a point, we can see where the XML. And you have the possibility, if you get specific information, to get this information in your tool without having to be linked in a browser. So you have everything in QGIS inside. And well, for the XML mode also work for sensor absorption service. As you can see, if we have some measurements, observations that are provided, we have also a tool that can give a linear representation of this time series. So this is something that our domain colleagues really like. And also we got a relational mode that enable to link data together. So you can see here the different links between the data, and this enable to the user to get to go data to data if they are linked. So as a conclusion, so in a nutshell, we will say that we have very encouraging points, because WFS and SOS really enable to provide data, but for basic usage, we have some identifiers, resolvers that enable to link data. We also have a QGIS plugin, which enables to consume the data. And thanks to this work, we have domain colleagues that can now test Inspire, and especially for source. And this is very important for us because it will open some door to have other projects and the others, to climb other steps. We also have other challenges to overcome, especially with actually the WFS app schema configuration is not really accessible, so it's very difficult to update our services at the moment. We want to enhance this. We also have source implementations that need one instance per use case, which is also a constraint for us. And we found that scalability and performances must be enhanced to reach production mode if we want to open our services to the world. We have to work on this. And this is the main message about this. Can we team up to finance the necessary evolution? Because I think we all have the same needs. And well, the idea is to have one solution for everybody. So can we team up to do this? So thanks for your attention, and well, cheers.
Thank you. Questions, please. Any recipes for cocktails? I think it was a very important point that you raised about the identifiers and the resolvers. I think that is one of the things that, from my opinion, is pretty much lacking in current technical guidance to how to make identifiers which are actually resolvable and link the different data sets and different services together. Just a moment.
Question in this context. I've seen that you resolve into GET KVP requests when you receive something. Is that necessary? In other words, as we have different protocols available like KVP or XML or SOAP or REST, is there anything that you would exclude for technical reasons, or can people choose freely?
Well, the idea was to enable. We don't really know what the consumer, what the user will need as a format to use the data. So we didn't want to close any possibility, and we offered this opportunity for the user to get the data in the format he wants, in fact. And well, as we are looking at maybe having a better understanding of our user needs, and maybe we will restrict the different format and also the requests that can be provided to the server.
Okay, so you have constrained yourself right now for reasons of resources, but you say you could extend into other protocols whenever needed.
Yeah.
Mm-hmm.
We
Thank
will
you.
try to.
Any other questions? From I think you mentioned at some point that you might want to or consider kind of restricting the web feature service just to support the predefined stored queries approach.
Yeah, that's
so. I think this is pretty much what's been done by the Finnish Meteorological Institute in the first phase of their web feature service. They only supported the simple WFS profile, which doesn't support the ad hoc queries at all. So I think that's possible.
Yeah. Actually, we found that we are possibilities to do something, but at the moment we can do everything we want. So we have to restrict and better understanding what our user need, and maybe provide some basic requests. And this will be done maybe with a resolver to be able to get specific requests, such as filtering of on spatial objects, on different things we identify as very important or most useful.
Other questions, Michael? No? Okay, thank you very much. Let's see. Yeah. Let's look at the data specifications. Or the Inspire themes. So can I have raise of hand from the audience? How many of you are, or your organizations are providing Inspire data sets from the Annex 1 themes? What about Annex 2? Good. And 3? Okay. A lot of, yeah. So just kind of the remaining time that we have, I think it would be good to investigate on the issues on how these different technologies that we've heard about today, what are the best ones to fit in which of the annexes and which of the data models. So if you have had some kind of implementation experience on some of these data models on these themes, I would like you to say that if you had any success stories, or you have had some problems in using some of the technologies or some of the products already mentioned today here, that would be really good for sharing that kind of information around the community. So what kind of service types are you using for? I suppose the Annex 1 is mostly Web Feature Service and Atom. How many of you are actually using or have existing Atom plus Open Search services for Inspire data? 1? Okay. What about Web Feature Service predefined datasets? By the way, there was one person who had done the Atom. What are you using for the Open Search implementation? Do you know, or do you have it? Okay, so it's a custom development, but you are supporting the Inspire queries. Yeah. What about the people who are using Web Feature Service? What technologies are you using, or which products? I think GeoServer was mentioned earlier. Who is using GeoServer for Web Feature Service? Okay, and who is using completely custom-built WFS, apart from FMI, I suppose? Yeah, that's not a wonder, because it's a big task to actually implement the whole web feature service standard. So what are you rest of you using for web feature service implementation? Those who raise their hands for web feature service, or if you know, you might not, of course, be that technical. Yeah. Yeah. Can you repeat?
We're using ArcGIS for Inspire.
ArcGIS. Yeah. Okay.
And I've personally done some testing with GeoServer, and I agree with the previous presenter that using the app schema extension is a little bit too tricky as it is now. If it gets more usable, I think it's a great solution. I know there's some projects trying to get Hail working with GeoServer and making use of the app schema extension. I don't know how far that has gone, but that should probably make for a wider use of GeoServer for web feature service.
Yes. So the GeoServer app schema extension was mentioned. That is a way to support complex features in GeoServer web feature service. And I think most of the Inspire datasets are actually, the data models are complex features, so you need something like that. Are you happy with the Esri ArcGIS for Inspire solution?
Thank you. For each version, yes. I mean, there were some difficulties in the beginning, but for each version that has been released, I think it's getting better and better. So I think their solution, especially for the web feature service, I think it's quite smart and easy to use. So yeah, I think it's good.
And which themes are you kind of providing data for?
Yeah, it's protected sites. Presently.
Protected sites, okay. Anyone else doing protected sites? One, yeah. There was a question, no? Just a minute. Meanwhile, others can think of extra questions.
The ArcGIS solution, does it have complex features?
Any other solutions they're using for web feature service? GeoServer, ArcGIS. Go Publisher from Snowflake was mentioned. What are your experiences on which data sets are you using it for, and what?
Protected sites, geographical names, administrative units, and I think biogeographical regions.
What are your experience on Go Publisher?
Well, it works fine. We didn't have many bugs, just 2 tickets, I think, and solved rapidly.
Yeah, my personal experience on that is that the Go Publisher solution is very nicely built, but it's difficult to support the Inspire metadata currently because you have to manually edit the capabilities files to actually include the Inspire extension, and that's a bit
for extended
difficult.
capabilities, we used the Notepad++ interface.
Mm-hmm. Another question here?
I'm from the Swedish Geological Survey, and it's a question for my colleagues in the other countries. There's a project called Minerals for EU that uses degree. Do you have any experience with that from the other geological surveys? Because we got a whole package solution with the database and the mapping in degree. No comments?
So.
Yeah, I think we got the same package from Gius about Minerals for Your project and implementing a degree. So we are actually working, we have got a proof of concept trying to make it with a GeoServer because we found that, well, it seems that the problem we got with filtering has not been solved by degree, and well, we are actually we have other solution using GeoServer. We get good experience on it, so we are actually trying to make it with GeoServer. And well, the idea is, I talk about GeoServer because this is something we are using, but the idea is, well, can we maybe team up to get, we have the same needs, and maybe work on the GeoServer or on other solutions that can provide the same data. So, well, we didn't work on degree anymore at the moment, but maybe if we can team up and finance maybe some work on degree, it's okay.
Any other comments on that? How many of you are actually already using web coverage service as something like Inspire or close to Inspire data models? Three? What technologies are you using for it? Which works?
Yeah, I work for the Copernicus Marine Service, and we don't implement WCS, the standard, but WCS-like. Mm-hmm. I mean, we disseminate data on the web and with the subsetting facilities on X, Y, Z, T. And we are using Threads data server and custom development on top of that to make it more robust and more operational, because Threads comes from research and university from United States, and there are best effort services, mm-hmm. Whereas Copernicus is more operational, so we put something more robust on top of that. And I have a question, mm-hmm. to if we want in the Copernicus Marine to become WCS from this WCS-like server, which document in which version do we have to follow to become standard?
Peter, do you want to answer that?
Now for the document, I guess that's the Inspire document. That would be the first place to hit. Yeah. And then of course there are forwards, there are links into the OGC WCS documents, and the WCS standard as such would be maybe the first part, and then looking into the coverage definition. That gives you the data and the service model. That's the heart of it. The core does just subsetting and delivery in some data format, so encoding, and everything else is an extension. So I have some very focused point to start with. If you want, I can send you the links. There is also a page, wiki, maintained by the Coverages Domain Working Group, where the specifications are available even when they're in draft mode, because sometimes, I shouldn't say that, sometimes OGC is a little bit slow, and so I publish documents while they are still under discussion so that people get informed and can give feedback.
Okay, so I do encourage you to work together in this, because FMI has now kind of hands-on experience on also on the same thing, the how to implement a web coverage service from a web coverage service-like service. So it seems to be a lot of interesting points there. I would recommend you all go and use the thematic clusters platform, which is a very good place for questions on anything related to this download services and also other Inspire issues. One more comment?
As you had been asking about experiences, mm-hmm. So there are services up and running that host 2-dimensional elevation data, 3-dimensional image time series, 4-dimensional weather data, and the largest database I'm aware of is currently 144 terabyte sitting at the European Space Agency, and it is planned to grow that beyond a petabyte within the next half year or so, roughly speaking. There are other installations at the European Center for Medium Range Weather Forecast, 4-dimensional WCS. We have 3-dimensional data at Plymouth Marine Laboratory. National Computational Infrastructure in Australia, so not quite Europe, but still, they host Landsat 8 image time series. So the standard as such has been proven that it scales up and that it can serve data conveniently.
Okay, I think we need to wrap up now, so it's we already 1 minute over. I would like to say that, based on what I've heard today, is that it's nice to hear that both the SOS and the web coverage service Inspire profiles are very close to the actual MIG approval. So the comments have been made, and so soon we'll have the official technical guidance for both of them. That's very nice to hear. And we've identified, I think, some of the things that how we want to evolve the technical guidance also. So splitting up the technical guidance in several parts, but still kind of keeping it together so there's pointers. If you just stumble into one of these documents, you find also the other ones that might be relevant to you. That's very important. I would also like to bring forth that probably the issue of identifiers and them being resolvable is something that we should discuss within the Inspire context. And once we agree on what model is really good, then have that included in the technical guidance so that we don't have to implement all kinds of different schemes on that. With that, I would like to thank you all. It's been very nice to be here for these 2 sessions, and thanks for any of your comments and discussion. And all the slides will be available in the Inspire website after the conference, and also the video recording of both sessions. So you can go there and get back the ideas, back to the ideas that were already raised here today. Thank you.